All right, trig, let's get into this. So we're in 4.7. We're looking at inverse trig functions. We just talked about what an inverse does. Inverse operations undo other operations. Inverse operation of addition is subtraction. Inverse operation of squaring something is square rooting something. So we need an operation to undo taking the sign of something, and it's called inverse sign. We've already mentioned this, and it's weird our book does this. Our book gives us problems and asks us to take the inverse like in 4.3, but we really don't actually officially cover it until now in 4.7. So here's the first little thing. Yes, in algebra land, x to the negative first power is 1 over x. That's with like exponent rules and things. But no, in trig land, inverse sine, that's what we call this, inverse sine of x, is not equal to 1 over sine. Okay, 1 over sine, by the way, is cosecant. It's its own thing. It's its own entity, the reciprocal functions. But this is not true. Don't fall for this. Inverse sine is its own thing, and that's what we're going to learn about today. Okay, so this kind of just recaps a little bit of what we talked about in the review. For a function to have an inverse, it has to pass the horizontal line test. Y equals x squared does not. It doesn't have an inverse. Y equals x cubed does have an inverse. It passes the horizontal line test. Okay, so with that in mind, I would ask you guys, and I'm going to do it myself and let you guys kind of just pay attention, but if you want to, it's good practice. I want you to find the inverse of sine, right? How we do that is we swap the x's with y's. Remember, inverse just undoes what the original function does. If I plug in an x, it kicks out a y. So if I switch them and plug in a y, it should kick out an x. We're going to switch the x's with y's. So what I want you to do is make a table, graph one period of y equals sine x. That's easy enough. We've done that. I want you to flip-flop the x's with the y's, and then I want you to plot those points and connect them as you go. It's weird to call it one period, and you'll see why when you start doing this, but we're going to look at one period, and I'm making quotation marks with my fingers, of inverse sine of x. Okay? Hit pause, try it out. Okay, we're back. I don't know if you do it. I hope you did it. So here is one period of sine, right? We found the period, 2 pi, cut it in half, 3 of those. We plugged them in. We've been doing a bunch of these. This should be old hat for us. So now what we're going to do is we're going to flip the x with the y. So this just stays 0, 0. That one's easy. My next point is going to be 1 comma pi over 2. Okay, where would that be? Plot it. Then I'm going to plot 0 comma pi and connect them. Then I'm going to plot negative 1 comma 3 pi over 2. And finally, I'm going to plot 0 comma 2 pi. If you do that, you get this funky S-looking shape. This is not a function. This doesn't work. Sine doesn't have an inverse, right? Mr. Edwards, you just told us to have an inverse, it has to pass the horizontal line test. Sine does not pass the horizontal line test. It wouldn't have an inverse as we're looking at it. And that's what we're going to get to. So this is sine. This is what inverse sine would look like. But that's not even a function. That fails the vertical line test. So that's no good for us. So don't memorize that thing, okay? Here's what we're going to have to do. We have to put our blinders on and only look at a specific spot of sine, right? This is one period of sine for sure, but it goes on forever. It goes to the left forever. It goes to the right forever. Why am I only looking at this first little period of it? I can look anywhere I want. And I choose, and everyone chooses, we're all in on this, all math people, all calculators, we've all come to this agreement, and now I'm bringing you guys in on the agreement. Whenever we're talking inverse sine, we're only ever going to look between negative pi over 2 and pi over 2. Okay, we're going to restrict our domain, our inputs. As long as our inputs are only between these two values, anything in between these two values and including these two values, then it would pass the horizontal line test, and it would have an inverse, and we can use it. Okay, so here's the restricted domain I just talked about. If we only look between negative pi over 2 and pi over 2, I'm cutting off all the rest of the graph and only looking at this piece. That passes the horizontal line test. This will have an inverse that undoes sine and gives me back originally what I plugged in. Okay. This is the last time. I mean, some classes have you like memorize this and do this, and that's okay. But this is what inverse sine would look like. X's and Y's got switched. Here it was negative pi over 2, comma negative 1. I flip those, and I would get negative 1, comma negative pi over 2. This one, pi over 2, comma 1. Flip them. 1, comma pi over 2. Okay, but this is what it would look like. This is what one period, if you want to think of it that way, of inverse sine looks like. That's all inverse sine looks like. We don't go anywhere else. Otherwise, it's not a function. Okay. One last quick thing on this one. Sometimes our book, and you'll see other books use this language, inverse sine of x, says the same thing as arc sine of x. Maybe it's because of that very first thing I showed you guys, that inverse doesn't mean 1 over, and that kind of students see this and think, oh, that must be 1 over sine. It does not. Inverse sine is a new function. Arc sine is a different notation for that same function. All right. Next slide. Moving on.